with that playing.
Sound.
Yeah. But otherwise it might work. Probably is.
Let me go and Paul. Let me just go and check up there then.
Do you want me to just? I'm pretty sure it's not working, but because I think what happens? You click twice there. Okay, so it's playing. It's playing.
Maybe it doesn't come doesn't show
Yeah,
on that
yeah. I
screen.
think it's worse. Let's just double check because at the moment we haven't got any problems.
I'll play one and I can switch it on the screen to make sure.
Yeah, so that is all fine. So this is running. What do you want to do? Do you want to?
Put it in twice and I'll just play it. I'll just switch it on the screen just to make sure it's coming out. We've got a microphone.
Yeah.
So you're happy with that? That's your first slide, is it?
Yeah, yeah. So there's no way to go through the whole thing, but that looks good. And the sound. So the sound sometimes it's quite the levels. So it hasn't been mastered.
Okay, right.
So are you gonna be doing the sound?
Ben's up there. Yeah, we'll give it a
Then the first track is like banging, so we'll have that. But some of them are like really crazy machines, and it might be really definitely. But the louder it can go, the better. Make sure you turn it down if it's like really crazy, because there's some really high pitched sounds there. Well, no, you should start, the first one's banging though. The first one's got like a proper beat. Let's to get everyone into it. Maybe, yeah. The one I just played there, that is the one that needs to be loud. But maybe if I get it like that, you guys can do it. Anyway. Can you hear the other stages when it's on? Is it the sound stage? I'm just wondering how the sound stage is. If it's is it alright? Like, if you sit there, it's fine. Perfect. Thanks very much.
that off. Just put it around the corner.
And then I'll cut. We're going to have to speak to the production company first. Ladies and gentlemen, we have our next speaker on Leonardo this evening. His name is Lawrence Kemble Cook, and he will be talking about how to power a city using kinetic energy from footsteps. So welcome, Lawrence, to the stage.
Thanks very much. Hello, everyone. Welcome. Now, I know it's a bit late in the day. Can I ask everyone to stand up who's here? Can you get up from your seats? Okay, so when I count to 3, I want you to jump in the air and then shout, "Hey," really loudly. Okay, so we're going to count to 3. Okay, ready? So 1, 2, 3, and hey! Okay, you can sit down. Thank you very much. Watch everyone pour in from either side here. Now, the reason for doing that was that we're going to see how much kinetic energy you can generate. Now, I think with everyone jumping there, you could probably charge a phone for about maybe 10 minutes or so just from that jump. But imagine if everyone here jumped together, and hopefully at the end of this, we'll see what we can actually do. Now, today, I'm going to tell you a bit about my story of PaveGen. And my journey. So I'm an industrial design engineer. I'm fascinated by the built environment in our cities. And I used to work at one of Europe's largest energy companies. And when I was there, I was looking at, could you power a streetlight from solar power or wind in our cities? Now, there's many common reasons why solar doesn't work when there's no sun, and wind doesn't work when there's no wind blowing. So when I was at this large energy company, I failed. As an industrial designer, I failed. I could not deliver a technology that worked. So I left that energy company and went to study at Loughborough University. I like to think of it in the UK as the equivalent of MIT. Now, when I was there, I came up with a concept of what if you could generate energy from every single step you make? What if you could turn a city into a power plant? What if you could turn every kind of moving space into something to actually create tangible power? Now, I believe that we've got to shift our reliance on fossil fuel. It's not all about having one big power station in the center of the country. It's all about decentralized power networks. And what does that mean? It's generating power where and when you actually need it. So that fed into the concept of PaveGen. It's a floor tile that when you step on it or when you jump on it, will generate electricity. It will store the power from your footsteps. And it's also got some really clever technology embedded within it. So this is made from recycled lorry tires. It's got embedded wireless technology that can send data. These things can talk straight to things like Facebook within it. They're really durable. I'm going to go on to talk about how durable these things have to be. And it's a real key component of what a smart city, we believe, will be. And what we do with that power. So with that energy, the ambition was to power parts of our cities. So to power things like street lighting, advertising displays, anywhere on the street that needs power. Now, a lot of people said, we don't believe that's possible, that won't work. when I phoned up the government helpline on how to start a business, they said, don't bother, it's not going to work. And this was in 2009. And luckily, we had some people say some nice things about us. So we had IBM say that this is one of the top technologies that's going to shape the future of our cities. And world-famous physicist Jim Akalele saying that actually this is a really tangible technology. Now, we had an exciting journey. This is my first prototype. It was made out of pieces of wood, some duct tape, some chewing gum to hold it together, but it showed the concept. And what happened was I had this wooden concept that when you stood on it, would generate some power, not very much, but some energy from a step. So I took it to a design show, and suddenly all the newspapers started talking about us and saying, oh, people phoning me saying, can I buy one? I had no product. Can I invest? I didn't even have a company. And can I distribute? I didn't have anything to distribute. So I had £50. I had a flat in Brixton, which is where I was living, and that was my headquarters of this company. And I founded the company in 2009. So to prove it is really difficult. So what I did is I broke into a school illegally. I had no certifications, no standards, and I installed the technology there.
No, I'm so impressed by this. I want to stand on it. But wait. Yay!
So what I'd actually created, I think, was I made energy-saving fun. Luckily, no students died when we installed it. There was a high chance of that. But we made energy-saving fun, and it showed it was a really engaging solution. Now, other things are, the ground is the hardest situation in the world to put technology. People are sick on you. People will try and destroy you every day. People have pickaxes, and they'll try and crush them. You name it, you're going to see it. So some of the things we had to do was build machines that would test that. So we have a rain machine that simulated what it's like. And imagine the atmospheric conditions of getting really cold, then really hot, and then repeating that for 20 years. Then people said to me, I don't believe that it really works in water. So we believe that you have to put your money where your mouth is. So we tested it to the next level. Now, this is almost showing that it works like a tidal energy device. There was no air, in the scuba diver's tank, but it looked like it, was a serious test like that. And then also testing the durability. So we had in my garage, we set up a rig that would simulate 1 million footsteps initially. This thing would go on and off for a month, every second, all the time, and it would have to. The machine broke quite a lot that actually tested it, but the core technology still really worked. And then we had to take it to the next step, and I call this, some people call it the human centipede machine that allows us to simulate a high footfall environment like a train station, and then assess how that power can be stored, can be captured, and then distributed, and actually knowing how the power curve works and being as efficient as possible is absolutely vital as we do that. And then I had to find a 50-stone woman in stiletto heels to test the technology actually worked. I couldn't find a real one, so we had to get a machine to simulate that excessive point load on a product. And then I got a phone call from the school that I illegally took it to, and they said, can we buy one? And now we have 1,100 students who devote every day of their lives to destroying PaveGen. And all they do is, as they walk down it, they just power the lights in the corridor itself from their footsteps alone. So we had some testing done. We had a first trial site in a school. And then we thought, well, what next? And what happened was the media helped us with that. So we had the Times write a little story about us. Then a few more people wrote about us. And then everyone started writing about us. And then will.i.am from the Black Eyed Peas phoned me up and said, yo, I want one of your PaveGens. And then David Cameron said he wanted some PaveGens in 10 Downing Street. We then went on and won some awards. Now, awards are great. You feel really good when you walk around with them. But awards don't really mean anything. It's all about product and actually getting it working. So we had some PR, some testing. We had a product. And then this is an example of what happened next with us.
Paris Marathon. 40,000 runners going to take those streets of Paris.
So what you saw there is we took it to an office, retail sites. We even covered the Champs-Élysées in Paris in paved Gentiles. So it's a really exciting journey from it. And for us, it was all about finding new places to use it. So I've just initially showed you a school, and you can imagine there's hundreds of places we could use this technology. So I like festivals, so I thought, let's take it to a festival and let's use it to generate energy to power mobile phones. I also thought, what about taking it to high streets all around the UK and in Europe and in America? So with fashion brand Uniqlo, we installed our floor in the entrance of their stores and actually used that energy to power part of the shop and also to drive a social media campaign. And then offices. So we found an office, and in 1 hour, we dropped in a floor. So you can see there's about to be a shot of an iPhone. That's giving live data of how people are moving through that space. Now, the boss said to me, I want to know when people are coming in and out of my office. I want to know when people come in late. And this way, online, he can get a readout in real time of where the people are moving. Now, that's one application. In the smart city of the future, everything will communicate with each other and everything will be networked. So lights that only come on when people are walking, and intensity that comes up and down, and in retail can be used to know how people move through those sites. So there's lots and lots of applications for it. Then we got a phone call from the Olympics, and they said, we'd really like to use a technology in a train station environment. So we put together this visual. We worked with them for a couple of years, and eventually we took it to West Ham Station, and this is an example of what happened. What we had here was 1 million people during the Olympic Games walking over paved Gentiles. We stored the energy from everyone walking in batteries, so it stood up and up and up and up and up. And then at night time, the lights came on in the station from everyone moving through it. So it's an off-grid station. It's the first time it's ever been done commercially in the world in that kind of setting. And you might see there's only 12 tiles there. We only had 12. That's all we'd ever made at that time. Now we're focusing on installations of 50, of 100 tiles and more on much larger sites. I'll go on to talk about that shortly. So some of the key things here is that we used our wireless in a slightly different way. So you could hover over each paved gen and see how many steps they had, so know how people move. And then also you could get trends over the month. So here you can see when Usain Bolt was running, everyone went to the Olympic Park to see him. And then you can see the spike on the right was when everyone went to go and visit Usain Bolt and see him running. So we started this thing called Paved API. So it's all about using that data to do something different with it. So imagine David Guetta doing a gig in Miami, using the data from people walking in London to actually provide the music for his set. And we want to open source this data and let people use that. And I believe that data is going to be so valuable in the future as we keep accumulating in every part of our lives. So other ways we've been using this API is I set up a dance floor for 2,000 people in Singapore. And I thought, well, it's all very well and good generating the energy, so we can store that power. And we actually stored it to power a cinema projector. But then what if you could do something else that would engage people online? So we made the dance floor tweet. And every 2 minutes, it sent out a tweet saying how much energy was being generated. I forgot to turn this off. And this thing kept tweeting and tweeting and tweeting. And what happened is it started trending on Twitter, what these people were doing in this dance floor and getting spread around that energy. So then we also thought of other ways we've done in dance floors, and we thought, well, could you do it for Christmas? Everyone likes Christmas, and we like Christmas lights. And with some help of some gnomes and some elves, we made a Christmas tree powered by people dancing on it.
Run, run, Rudolph, Randolph ain't too far behind. Run, Rudolph, Santa's gotta make it to town.
So that's a fun example of how you can use energy harvesting and the data in an environment that can, I suppose, get us a marketing budget to allow us to put a project in there. And why is that important? I suppose early projects for us fund our R&D and our development, so it's really important to get a market and get a product out there quickly whilst we're developing it for the end goal, which is every floor to be covered in PaveGen, and every person moving will actually start to have a payback model with that technology. That's where it's going to get to. So we're now on this side as we're developing it. So what you can see here is the Champs-Élysées. We thought, wouldn't it be great to utilize the energy of 37,000 runners and turn that energy and store it and do something with it. So we didn't know how long it would take to install nearly 200 tiles on the Champs-Élysées. We guessed and said maybe 4 hours. We had a team turn up, and this is what happened. So we managed to install it in 55 minutes, so record time. And then when the runners came down, what we did with their energy was not only storing it in batteries, but also sending that data so people can see and actually have an understanding of what that energy means. So you can see here the billboard that was up that's giving a real-time display of that power that's being created. And what we did with that power is we took it and we actually donated it to schools in Paris. So it was a way to actually give something back from people moving through those environments. Now, I've just got off site this morning. We've just installed our largest installation in a corridor that is storing the power and actually powering the lights in the corridor itself. Now, I've talked to you today about some applications for it, now from footsteps alone. But imagine what's more than footsteps, cars. Okay, cars have 2 axles. If a human weighs, let's say a heavy human weighs 100 kilos, a car is easily 1,000. So you're looking at a lot more potential power to harness. And some really interesting statistics are there's more copper in the streets of New York than there is left in the world's reserves. So the energy of running those cables is actually, we're not going to have much copper left. And everyone's got iPhones and all the energy used in the copper within them. So if you can create power where and when you need it, it's going to be more and more important in the future. So this is something we're commercializing at the moment. And you might think, where else can we generate energy from movement? What about shoes? So I don't know about you, but my iPhone maybe lasts me 5 hours when I'm really busy. And my Nokia used to last me maybe 2 days 10 years ago. Now, what if you could charge your mobile phone just by walking? Now, technology exists, we've proven it, and it's all about getting the right interface and the right way to scale it, to make the right amount of products actually work. So it's interesting talking about scale. I'm really fascinated by how to scale something, because there's lots of great ideas. There's lots of great ideas just wandering around here, and everyone in this space has got the ideas. But it's actually how do you get it from an idea through to something that you can make, has to be profitable a bit, so you can employ people and have an office and have all those overheads that come with running a company. So I think of it a bit like the chasm of doom, okay? So this chasm represents a journey of an idea through to something that's commercialized. So what happens is first is you can see when an idea is early, people will pay a lot for it. So imagine an iPad. People would pay £1,000 for an iPad, but only a very few people would actually pay that. The trick is to reduce those costs to allow mass market adoption. So what I call it here is you've got the early adopters, the people who buy it regardless of the price. And then you get to a point where you max out your market when there's no one else left to sell to at that price. So you've got to scale up, you've got to build a factory, or you really scale your business through sales and distribution channels to get that. So this is a chasm. Now, as you go through the chasm, you've got to make lots of really good decisions. If you make anything wrong, like you think, we're going to sell 50 million iPads in the first day, you might build a factory so big that you can't actually sustain it. And then what happens is you can often plummet off the bottom of the line and die, which a lot of companies have done in the past. Or you can just about scrape through and get so close to the line as you've made your investments to scale that you get in the tornado, the mass market adoption, and then eventually, I suppose, it gets to the end where you're making a mobile phone that was this big, say 15 years ago. There's no market for them anymore, and then you've got to keep innovating. And it's called the innovation, I suppose, bell curve. You've got to keep this process always going with new products and new technologies. So how are we doing that? I guess what we're doing is, right now, there's a high embodied energy in our product. It's relatively carbon intensive to make because we are on Mark 1, so we use a lot of steel in it. But the next model, when we've got more scale, will allow us to use things like recycled plastic concrete. We need the tooling for that, but as we develop, we'll be able to get that tooling and invest to allow us to reduce the energy in making it and to use as many new low-carbon technologies as possible. So eventually, it's all bioplastic, it's really thin, there's hardly any virgin material, and it's all from recycled materials. And that's our ambition, and we're well on that journey to do that. So I've talked of smart cities. Now, I think that as we scale it, the smart city of the future will be made up of a number of different technologies. So we're looking at, hydrogen fuel cells will play a part of that. I think that solar PV will have some massive advancements. I think wind's got its space, but not necessarily in cities, and maybe it will in 10 years when someone's innovated. So the makeup of the energy hasn't even really been decided yet. People have got ideas, but it's not set in stone, and technologies like PaveGen will build like a small part of that energy mix, but it's got to have a whole variety of things to make that happen. So I suppose that is an introduction to what we're doing in our journey, and I'd like to say thank you very much, and if anyone got any questions, I'd love to hear them about PaveGen, so thank you. Thanks.
May I ask you what's your role in the company?
I'm the Chief Executive Officer.
And you are also the engineer.
I used to be the main engineer in the company, and now we have an engineering team that I oversee and that lead strategically on that.
Okay, thank you.
Thanks.
Sorry, but how does it work actually on the inside?
So I've got a couple of answers to that. Now, what we have, and the core part of the technology, is a really efficient way to convert your downwards energy of a footstep into electrical power. And what that does is it gives you a constant pulse of energy. So that burst of energy will last for 1 to 2 seconds per footstep. Now, it's not something based on piezoelectric principles that you might be familiar with. So piezoelectricity is an electric lighter that will spark. So you depress a crystal and it sparks, and it gives you really short spikes of energy. So what we have is a hybrid solution that gives you those prolonged bursts. And I can't really talk much more about exactly what's in it, but it's a lot cleverer than like a piezoelectric solution that can be scaled and is much more durable.
Well, how many footsteps are necessary to repay the energy that was necessary to produce it?
So how much energy how many footsteps are needed to offset the amount of energy used to make it?
Yes.
Their question. So the product at the moment, I think I said at the end of my talk, there is a high embodied carbon in that because we're not able to use production process with a really low embodied energy. So we know that it's really high. Like we're well aware of that. Now, as we scale it and we get to a point where we're using these recycled biopolymers, and we use at the moment recycled lorry tires and more of those things, we believe we can get to a carbon payback of under 2 years for the product, but we're well aware and we're transparent about the fact that it is high right now because we're in that kind of low production space. Thanks. Yeah.
What is the weight of each tile, and also
what is the cost of each one?
Okay, so what is the weight and the cost of each product? So the weight and the lifetime. Okay, so the weight of each product is about 28 kilos. The new model is dropping to about 20 kilos. So we're making it a lot lighter, a lot easier to handle and move around. The cost of the units, they change all the time. They go down by huge amounts. So when we first sold products, they retailed for several £1,000s for one. Okay, so really, really expensive. Why? Well, when you're a startup with only a few products, you've got to keep your prices high when you've only got a very few amount. Now, we've bottomed out the price significantly compared to what it used to be. So it's under 1,000 and way under on quantity. So like a lot, much less. Our aim is to make it cheaper than normal flooring. So this stage could be about £200 a square meter fabricated. So we know we can get under that. And offices, the flooring there, we know we can get under that eventually. In terms of lifetime, we've never had a product fail. We've tested it up to 40 million footsteps with no failures. And those tests keep going and going and going. And we'll really have the answer when we've had that failure, which I suppose you could compare us to LED lighting. When they first came out, people said, yeah, 5 years. 5 years is all right. After 5 years, they said 10 years, 10 years. And now they say, well, you can get 25 years plus from an LED fitment. So we're keeping, watching it and seeing how far we can get it. And we're making improvements all the time. But it's also a balance between efficiency, power, and cost. And like, what's the most important one to put all the money into is really important for us. Was that all your questions? Thanks very much. Thanks.
The elements we saw has a relative small area for the pressure instead of the total module. Isn't it much more clever to use?
I'm going to stand next to the speaker so I can hear you. Say it a bit louder.
Hello.
Okay, I got you there. That's good. Yeah.
The question is, the elements has a relative small area on the module for the pressure to use the energy of the steps, and isn't it not much more clever to use all the area of a module to save energy? Isn't it a technical question to use all the area or small area of the module?
Okay, yeah. So each tile measures 600 millimeters by 450. Okay, that's a product that you'd buy from our company. Now, the one thing that's really clever about what we've done is there's only one generator unit within each product, so it helps reduce the cost. So if you had 5, it's going to be more expensive. Now, what it actually does is the slab deflects just 5 millimeters in the middle when you walk on it. And the reason we do that is because it's compliant with all the British standards, because otherwise people can trip over it. So it has to be really, really smooth as people use the product. Now, energy will be generated from about 80% of the product. So the edges don't move. The edges are completely fixed so that we can there's no trip hazards. People fall over all the time on floors. So we have to have that fixed. So 80% will give us energy. We're improving the space all the time because we use a special composite material on the top that allows us to have that properties from it. So it's getting better, but 80% is about the ballpark range of where we're getting an energy transfer from each step from. Thanks.
How many steps are needed to produce more energy than you put into it during the production of the product?
So on average, we look at this is when the earlier question referred to, we aim to get a 2-year carbon payback on the unit when we've scaled it. So at the moment, we're not in that area. But that's based on a high footfall environment over that 2-year period. So you'd be talking in the kind of low millions of steps to get to that number, give or take on it. Anyone else got any questions? I think we've got one at the front and one at the back. Back's nearer. No? I'm making your life easy here.
And you were talking to use it with cars also, but what is the maximum weight the tile can support? I mean, what is the limit?
Okay. We tested it over and beyond what the standard said. which I think is 50 tons distributed over a 1-inch square. I think I can't remember how many kilonewtons exactly, but over 50 tons over 1-inch square. So we've tested it through like crazy levels, and we've driven cars over it, over the current models. We didn't know it would work, but when we drove it, it was fine, and we drove cars over it all the time. So the key thing about what we've done is we made sure that fire engines will drive on it. Maybe a tank will go over it on the street. You never know what will happen. So it is engineered to withstand really high forces. With a vehicle system, it's got to be really strong. I'll give you an example. A truck going 50 miles an hour that slams its brake on will rip the tarmac off the road because of that huge forces that are interacting there. So our product, when it gets on the road, has got to be able to take that huge forces, and I think it is a big barrier to overcome. And you've got to be, I think, with engineering side of this, you've got so many different aspects that are all really important. If one goes wrong, you're in massive trouble. If it's too expensive, no one's going to buy it. If it freezes at -50 and doesn't work, no one's going to want it. If it gets too hot and explodes, it doesn't work. If water gets in it, so you've got all these different things that need to be thought about in the initial design brief, which is what we do for every new model and every new iteration that we're producing. Thanks.
Great idea. Thank you for that. And
Thanks.
I want to ask you, do you have any competition on the market right now?
So we focused, since we first started, as a floor tile for the built environment for our cities. So we're really focused on busy outside areas. Now, there are people who are looking at it in the dance floor world. So if you want to buy a really cool dance floor, there's companies out there that will just make a dance floor. But we're really focused on the different side. It's a slow market. It's quite hard because no one would have had this idea to buy it 20 years ago or 10 years ago. They said, I'll buy solar, I know wind. What? Footsteps. People didn't even understand this was real back then. So we focused on this kind of hard market, but now it's starting to show a lot more traction. And we are seeing more and more competitors pop up who are really new and trying to get into this market as well. And I think that imitation is the best form of flattery. And all it does is keep you awake later at night and keep you working harder when you know you've got 20 guys on your tail trying to do something different. But we are we see ourselves as the most commercialized and the biggest company doing it in this space, even though we're still really small, but bigger than anyone else doing it. Thanks. One more back there, and
Hi, couple of questions. Are there different models? We saw there were red tiles, and there were tiles with lights fitted in them. Why would you fit a light in something that you're trying to save energy?
Yeah, it's a really good question. Now, we had the light initially because when we launched, we wanted a kind of really good marketing story. So we put a light in, and it was fun, engaging. People would play with it, and that helped launch us. And then we realized that it's not really a proper solution down the line, but it was really cool for getting journalists interested and getting people jumping up and down on it because they can see the rewards. The only thing that was really good about it did give people the reward that made energy saving fun, because I wouldn't necessarily just jump up and down for no reason, but if I got that reward, that would make it a bit more fun. So it was important earlier on, but now we've phased that out. In terms of other models, we only have one main product. What we do is we can customize the top. So the standard thing we make is a recycled truck tire. It's about 95% truck tires, and then 5% is the binder. But we can put on top of that different things. So the office, we can put carpet, we can print stuff onto it. So we work with architects who are really fussy. Sometimes, they'll spend their lives getting the Pantone of that floor to match the chair. And we made sure that we can deal with people like that and do really nice jobs by putting on vinyls, different colors, and all those different solutions to make it a really functional product. And I'm really into entrances of buildings at the moment with very nice gratings. We're trying to get a really good grating product on the front because every building needs that. And when you're cleaning the feet, why not actually do something with that movement of that kind of people going through it?
Just one last question. How many tiles would you need, and how many people would have to be walking to light up a hallway?
Okay, so the typical amount for a hallway is you'd be looking at about 30 tiles plus in that hallway to make sure you're getting maximum foot flow. So you don't want it to go right up to the edges of the building, because, or the walls, because people don't walk along the walls like this. In terms of the amount of people going through it, it needs to be high footfall. So schools are good only in busy corridors. So a school of 1,000 is a tangible number to actually do something with, but not a school of 50 where you're getting, because at 50, the way I look at it is if there's 50 people, you might get 6 movements a day from those people. So you're looking at under 500 steps. So it's not really enough in that scale. You want the thousands. Then if you look at the other extreme, you look at Victoria Station in London, these guys are getting 35,000 people move through one space an hour. And so you put 40 tiles there, you're going to be getting 30,000 plus, or multiplied by 40 if each person stands on it, give or take a bit. And then you're looking at an order of magnitude more energy from that kind of space. So we do focus on that. We have, people have said, I've got a horse training ring, can I put them in there? And we think that's a bit crazy, but we see all sorts of kind of ideas of where to use it. But it's not something to put in your house, at least not yet. We will find another solution where it's like a consumer type product to use. Thanks so much for the question. Thanks. Any other questions at all? Great. Thank you very much. Thank you.